All right, let's dive into another Mtel question. This one says, use the table below to answer the question that follows. We've got some information about bagels, pretzels, and their prep time, bake time, and some profit, depending on how these factories are operating. And then the information from the question is that the manager of a commercial bakery uses the table above to optimize the profitability of the bakery. The bakery's preparation room can operate for up to 16 hours per day, and its baking facility can run for up to 12 hours per day. If B represents thousands of bagels and P represents thousands of pretzels, which of the following graphs represents the linear programming problem? Cool. So we can make a couple inequalities from this information because we know that the prep room can be open for up to 12 hours a day, and prep time for each of these things are 2 hours for bagels and 4 hours for pretzels. We can create the inequality 2b, so 2 hours for every 1,000 bagels for prep time, plus 4p, 4 hours for pretzel prep, has to be less than, so that's the total hours of prep time, has to be less than 16 hours a day, which is how long the prep room is open. We could do the same exact thing for bake time. So since we know the baking facility can only be open 12 hours a day, we're taking 3 hours for bagels plus 1 hour for pretzels, and that is going to have to be less than 12 hours. So in terms of these lines, I like to think about the intercepts. So all of the answers are trying to graph these two inequalities basically. And in A, our intercepts are for one of the lines are 12 for pretzels and 4 for bagels. Well, that's a representation of the second inequality. If we were to make 0 bagels, then how many pretzels would we be able to make? P would have to be less than or equal to 12 if we plug 0 in for B in the second inequality. So let me just do that quick. So I'm just plugging 0 in for B to check basically what our intercept would be on this line. So if I plug in 0 for B, if I make 0 bagels, then I can solve for how many pretzels I'd be able to make. And pretty quickly I can see that P has to be less than or equal to 12. And that's this point right here on the graph. Alternatively, if I make 0 pretzels, then I get the equation 3 times B plus 1 times 0. So this time I'm plugging 0 in for P. That has to be less than or equal to 12. So you get 3B is less than or equal to 12. So B has to be less than 4, which is this point on the graph. So A and B both have that line graphed. So I know that my answer must be either A or B. C and D have the wrong lines graphed. Our intercepts are incorrect. 8 and 4 are not the correct intercepts for this particular equation. So I can immediately eliminate those. And the only difference between A and B is the shading. Well, we have two equations that overlap at these points. And in both instances, we have to be less than those values. So the answer that we're looking for here is the answer that shades below both lines, and that answer is A. So this little area is the optimization for this particular question.